Welcome everyone. In this lecture we will be studying about hydrology. Primarily this will be based on S.K. Subramaniam work. So let us begin. As we know that all around us we see water in various forms. Basically hydrology is the science which deals with occurrence, circulation and distribution of water. Occurrence means how does water on the earth and in various forms, how does it come to be, how does it occur. Circulation means how does this form of water circulate from one place to another place, and distribution means what is the ratio in which various components of water are distributed. Basically hydrology begins the study of basic cycle called as hydrological cycle. The cycle, we have a prime source of energy which is our sun. It also gives us solar energy, and it is through the energy of sun that we get to drive this hydrological cycle. So the cycle begins like this. We have sun which emits radiation, and as soon as it reaches earth's surface, there are water bodies such as oceans, lakes and rivers. From these water bodies we have a process called as evaporation. Evaporation is the process where water molecules leave the water and enter into a vapor state. Now water vapor is transported and it becomes cloud. After the temperatures comes down, there is a process called as precipitation. Precipitation does not mean that it will only rain. Precipitation may occur in various forms such as rain, snow, hail and other forms. So due to the condensation of water vapor, which was earlier a part of ocean, now we have water molecules from sea right up to the clouds, and then from clouds we have our own precipitation cycle. So after the rain, this is our earth surface. Here there will be two things: a waterfall here, then either it may run off. It means that either it may go along the slope or it may come down into the earth surface. So the water which goes along the earth surface is called as a runoff, and water which comes into earth surface is called as infiltration. Now the runoff portion keeps on coming, and somewhere it meets a water body. It may either be a lake or ocean or river. Now the part which has infiltrated, it becomes a part of groundwater. Groundwater is that water which is stored in the form of water at the ground, below the ground. So this groundwater also contributes to water bodies such as river. We look at various terms in this hydrological cycle so that meaning is clear. So first let us look at what is precipitation. So as we have seen, before precipitation there is one more thing, evaporation. So evaporation is transfer of water molecule from liquid state to gaseous state. Very simple, from liquid to gaseous state. It is from oceans to cloud, you can say like this. Now we have precipitation. This is deposition of water. Deposition, it does not mean only rain, it contains all form of deposition of water on our surface from clouds. Deposition of water in form of either rain or snow, or you can say hail or frost, anything like that. Now we have interception. Interception is, suppose there are clouds and it is raining. So if there is tree, then over the tree and other vegetation there will be interception. Interception means water molecule will not be able to reach the ground surface. It will be intercepted by this vegetation portion. This is our cloud, it is raining, and here is our vegetation. It does not allow water to reach ground surface. Now let us see what is infiltration. It is the movement of water through the earth surface, in the earth surface. Basically this is our ground level. So if rainfall is coming here, then the water which percolates down below the earth surface, this process is called infiltration. Infiltration. Transpiration is the soil moisture taken up through the roots of plant and discharged into atmosphere through the foliage by evaporation. It means we have our plant system here. These are our trees. We have then leaves, and it has its root. So below the ground level, uh, its roots are taking water from the available moisture, and this water is going upwards the tree and through the leaves. It leaves the earth surface, or you can say it evaporates. So this process is called transpiration. The discharge of moisture into the into the atmosphere by the plants and trees. Discharge of soil moisture into Earth's atmosphere, to the atmosphere. Now we have interflow. Interflow is that thing, and like suppose you have groundwater here, and this groundwater, if the water comes through, if it's water, there is infiltration. It means water has infiltrated into our surface, but again this water goes on to meet any other water body, comes to the surface. So it does not, you can say these two paths, this path that is coming through the ground surface and this path coming over the ground surface. These two paths are, first this is known as runoff and this is known as interflow. This interflow. And surface runoff, as I've told you, if there is mountain and this is our river, if rain is falling it will go as surface, or if there is percolation it goes as interflow. So surface runoff is that part of water which is drained at the outlet or of a catchment. This is known as outlet. This is our catchment area, which I will explain later. So we have seen basic hydrological process, and these terms are important for understanding the basis process, because we will be using specifically like infiltration and surface runoff. These terms will be used frequent in analysis of our concepts. Also we will be looking at how the various water resources managed through the study of hydrology, how we can calculate precipitation runoff, and how we can predict drought or floods in case of an we will also be looking at some models to predict what will be like kind of situation when there is when there will be flood, or what situations can lead to drought, or how much water is essential for farming, and these things like that. So in this lecture and in this series you will be getting basic idea about this concept of hydrology, and this can be used for your study in courses of civil engineering, such as your classroom study or kind of preparation for examination. uh, it will cover almost every aspect which is related to the subject. So now let us see transportation component and storage component. Transportation component mean how the water can move. So we can see water moves through evaporation, precipitation, transpiration, filtration. These are the various ways through which uh, water molecule or the one form of water moves through one place to another place. Now storage component means uh, what are the various ways in which water can be stored. So water is stored on land surface, means either in pond, lake, river or ocean. These are the storage component on surface. It also gets stored in groundwater, and last but not least, as water is also stored as soil moisture. As we have discussed earlier, that all the hydrological process only occur in the presence of sun. So our energy is derived from sun, and there is no gain or loss of energy. Only one energy is converted to another form. So mm, keeping this in mind and other aspects, for applying engineering applications, we can say that study of hydrology is absolutely necessary for managing water resources and understanding the basic cycle of water. Now let us come to a very interesting concept which is called as catchment area. Catchment area. As you can see by name only, we have that it catches something. It catches what it catches. It catches water or rainfall or precipitation. Water or precipitation. Basically, it is used in concept of rainfall or stormwater. Let me say that this is our mountain. I am showing you elevation. This is also a series of mountain, and you can say this is your kind of a valley like thing, very steep mountains. So if what will happen, and there is a river going through this mountain at the base of this mountain, which is generally the case in uh, most of the water system. There is a river which comes down the slope. Now if rainfall takes place, then we will see that all the water which falls on this area, this, it will drain here. It will drain in this river only. I'm just trying to give you an idea that what does a catchment area mean. So let us start with a simple concept. Catchment is that area. Catchment is basically an area which drains means all the water falling in this area will come here, means whatever the river it is flowing, and or any source of stream. So if all this area drains into this river, if all the water falling on this land will come in this river, then we can say that this is our catchment area. This will be your catchment area. Let us you can say that there are few more terms to denote catchment area, such as drainage basin, catchment basin, drainage area, river basin, water basin. All these things basically mean the same, that whatever the area is where rainfall is falling on that land, it will drain into a particular river or a stream of water. Now we look at what is called as watershed divide or topographic water divide. Watershed divide is that concept which says that which separates two catchment areas. Let me tell you. Basically, suppose we have two rivers flowing like this and another river flowing like this. So if we have, this is our watershed divide, this line. So if rainfall falls here, it will go and meet this river. If rainfall comes here, it will go and meet this river. So this line will become what is called as watershed divide. It will divide two catchment areas. Basically, this divide follows generally a ridge line, means it is a meeting point of two mountain series, or it is a ridge. It is a high elevation area. High elevation. It has high elevation as compared to both of these rivers. Now, I think we have understood what is catchment area and what is watershed divide. So let us move ahead and let us look at what is called as catchment leakage. Catchment leakage is a concept which explains that if rain, this is our, let us say it is our watershed divide. This divide is called as watershed divide. So if rainfall falls here, half of the water will go here, and if it comes here, it will come here. But if this is a called as our groundwater divide, it means it separates the flow of groundwater uh, with respect to both the streams. Groundwater divide. Now, if water comes in this portion, because there is difference between this watershed topographic water divide and groundwater divide. So these do not match in some cases. So if water comes here, fall in between these two divide, then it is most. Then what will happen? That water will come and meet here. Water flow will occur like this. Water flow will occur like this and meet a stream somewhere here. So what has happened that water which was part of this watershed divide has come to this. So this is called as catchment leakage. Means this water has leaked from this water amount has leaked from this side of the catchment area, which happens when groundwater divide and uh, topographic water divide does not match. But for large catchment areas, this leakage is neglected, and these two lines are to coincide. Hydrological budget equation is a basically continuity equation. It is also called as a water budget equation. It says that whatever water is coming, means whatever water is coming in dam or river or any water body, is called as inflow, and whatever water amount is going out is called as outflow. So water which has come minus water which has gone out will be equal to change in storage. But if 7 meter cube comes and same amount of water goes, then there will be no change in storage, because there has not been any addition or subtraction of water from this water body. We can see this equation in detail. This is a detailed water budget equation. This is P. P means precipitation. Precipitation is whatever the water is being added. Now R is runoff. Runoff means whatever water has been lost. E is net evaporation. Whatever water lost due to evaporation. T is net transpiration, water loss through leaves of the trees. Transpiration. G, whatever groundwater flow is there, whatever water has been stored in the form of groundwater. So we have our P was the main source of water. We can say that it was inflow, and all these things can be said as outflow. Now inflow minus outflow, we can label this. This will be our inflow and this term here is our outflow. Outflow consists of runoff, evaporation, transpiration, groundwater storage, and this net will be equal to change in storage. Either it will increase or it will decrease. Depends on which term is greater or lesser. In terms of rainfall and runoff equation, rainfall runoff equation, it is very simple. We say that there is precipitation minus loss. Whatever losses are there, it will come as R. R is runoff. Whatever water has run away. So whatever water is falling here and whatever water is lost, final the thing which reaches here is called as runoff. And the total amount Q, suppose Q amount of water has fallen, and it will be Q dash, because these two water is not same. There is loss in the form of, as I told you, transpiration, infiltration, percolation, groundwater storage change, interflow. So this is our rainfall runoff equation. It is an important equation. We will be using it later classes. Once again, let me write it like this: runoff is equal to precipitation minus losses. Runoff is equal to precipitation minus losses. Now let us look at the global water balance. Global water balance basically comes to a point where we have to look at what is the distribution of global, means Earth's water, in what form these are stored, and what are the various percentage according to which they occur. So as we know that most of the water on Earth is in oceans, 96.5%, and it is a saline, very big saline source of water. Basically, we cannot drink ocean water because of high amount of salinity in it, and this does pose a major global water crisis problem. That we have so much water, but we cannot use this water as a drinking purpose. So our 96.5% of available water is in oceans, and it is saline. Then we have other saline sources of water which constitute about 1%, such as lakes and other saline water bodies. Then we have fresh water, which is only 2.5% of the available water on the Earth's surface. Now let us see this distribution of 2.5% fresh water. Out of this, we have glacier and ice caps. We know that we have two major ice caps, north and south pole and surrounding areas. So we have big concentration of glaciers and ice caps on both the poles of Earth's surface on the north and south pole, which constitute around 68.6% of fresh water. Then we have 30.1%, which is of fresh water which is stored in groundwater, and now we have 1.3% of available fresh water which is stored as surface water or other fresh water. Now we can have a look at distribution of this 1.3% of fresh water. Out of this, ice and snow constitute 73.1, lakes constitute 20.1%. Now we have soil moisture, rivers, swamps, other living beings, atmosphere, all these things in very tiny fraction of a very tiny fraction of a very tiny fraction, you can say. And we are passing through great changes in our structure and our modes of consumption. So basically, if we are not able to um, generate adequate amount of fresh water for drinking and other purposes, then we will be looking at very bleak scenario where basic drinking water will not be accessible to most of the populations on the earth surface. Therefore, we have to look at those sustainable ways where we can either use we can use those processes which consume less energy for cleaning ocean water, or we can look at the ways of filtration and cleaning our rivers and basically putting an end to polluting. And most of all, we should uh, we should not waste water where it is not required, or even we should take care that all the water and all forms of water used by humans should be in a very judicious manner. So, in this series, we have seen introduction to hydrological processes. We have looked at hydrological cycle. Then we have looked at various terms, evaporation, transpiration, like this. Then we have looked at catchment area definition, drain, catchment area divide, watershed divide. Then we have looked at catchment leakage, then hydrological budget equation, where is inflow minus outflow change in storage. Then we have seen Earth's water distribution. So let me know if there is any improvement you would like to see, or any mistakes that I may have made. Leave in the comment section below. Thank you.